All right, are you? Welcome back to this channel. In this video, we are going to be talking about lines, triangles, and circles. All right, and we will be taking it from the scratch so that you can understand well enough to be able to attempt any question under circle theorems, lines, and shapes as regarding and triangles under this topic. All right, so let's begin with what is a line or what are lines? What is a line? 2 points, yes. So a line is a distance between 2 points. All right, so it means that I could pick a point A here. When we're dealing with Cartesians, we said, hey, so we could just pick a point. That point will have two coordinates, right? Right. Then if I take from that point A, and I take another point B, say here, or maybe anywhere, just I can fall anywhere. Yeah, I take a point B here, and I'll say what is the distance between them. I can connect them with a line to tell the distance between both of them. Do you understand? So the length of this thing is going to be the distance between them. And so that's what a line is. So, and why is it called distance between 2 points? And in fact, there are infinite number of points within a line. Is that okay? So if I can break it into the tiniest chunk, the tiniest bit, you know that I see have points. Those are points, 1 point, 1 point. All right, so if I aggregate them together, all right, so that's a line. All right, now, what is a triangle? Is a polygon, yes, that contains 3 sides and 3 angles, and is the simplest polygon. Is it what? Simplest polygon. Do you know how to draw the polygons, like from at least 3 to 10? Are you sure? Have I showed you how to do it before? It's simple. You go from 3 shapes to, which I will show you later. But let's see this. So my point is this now. We've discussed what line is. So what are the types of line we have now? Or no? What are the languages we use to describe line? We use what is called the line segment. Yes. So what's the line segment? A line that is bounded, right? So yes, between 2 points, it is bounded within. It has two boundaries. Do you understand? So if I say A and B, for example, this is bounded. Even that one I drew the other time is bounded. Is that okay? But they are boundless lines. Is that okay? For example, I could just draw a line like this. This is boundless. So it means that this line can continue to infinity on this side, can continue to infinity on this side. Do you understand? All right. So, and that is why you must understand what we mean by this. Because in some of your questions, most of your questions will give you shortened lines that you will have to by yourself continue, or will I say discontinued lines. So you are the one that will continue it so that it makes sense and is able to fit into the laws that you already know. Do you understand? All right. So there's also there's ray. All right. So a ray is bounded at 1 point and then it continues on the other side. So it is continuous here to eternity. Is that okay? So you can continue to draw it. So most of the times for your shapes, are going to be giving you rays to work with. Ray. I mean, many ray. I mean, this is not physics, but when you have many rays together, what do you call it? Or what do you call them? A beam. Beam of light. So this is a ray. One of them is a ray. All right, and you see, it makes sense because even from that light state, this thing, from that light phenomenon, there is a source, right? So it's coming out of that source, right? So that source is going to be the boundary. God bless you. The lower boundary then is continuous like that. All right. Now let's talk about what is called collinear points. Collinear points. What are collinear points? A collinear point, if I say 2 points are collinear or 3 points are collinear, it means they exist on the same line. So if I have my line here, If I pick this point here and pick this point here and this point here, they are collinear. If I have this line intersecting this line, now listen, calm down. If I pick this, the lower boundaries of these lines are collinear. Look, this part is collinear. Why? Because they exist on the same line. Is that okay? But if I pick a point here and I pick a point here, these two are non-collinear. Do you understand? All right, so we have collinear points and non-collinear points. All right. So the next thing to talk about is also condition for parallelism and perpendicularity. So we have what? Parallelism and perpendicularity. So what is parallelism? So for example, look at this thing, these two lines. Or look at this board, in fact. Why does is this board straight throughout like this? Yes, it is. Or at least it's presumably straight, right? Why is it straight? God bless you. The same distance throughout. So two lines are parallel if they are equidistant, if every point on those two lines are equidistant from each other, are of equal distance. If so, two points are parallel, two lines are parallel. If every point is equidistant, or if every point you get it, are equidistant from each other. Do you understand? So from here to here is the same as from here to here, same as from here to here, all through. Do you understand now? So that is what you call parallel. How about when you want to define in terms of degrees? When the angle between them is what? 0 grams. Do you understand? All right. So 2 points. The condition for parallelism is either we say that both lines have equal distance between them. So, and they could be going, now another thing is that they must be going in the same direction. Because if they're not going in the same direction, maybe I didn't mention that before, they are called, if they are still maintaining equal distance, if they are still equidistant from each other, if every point is still equidistant from each other, but they are not going in the same direction. Maybe this is a ray going in this direction, and this is another ray going in this direction. These two things are a special type of parallelism called anti-parallel. Do you understand? Parallel means they are going in the same direction and they are also equidistant from each point is equidistant from each other. While anti-parallel means though each point is equidistant from each other or they have 0-degree angle between them, but they are moving in different, something like this, directions. Do you get it? So this one is going this way, this one is going this way. Do you understand? All right. So now, how about perpendicularity? When the angle between them is what? 90 degrees. Do you understand? So we said for parallelism, 0-degree angle between them. This one, 90-degree angles between them. Do you get it? All right. Now, if it's less than 90 degrees, you call it acute angle. First, what is an angle? Angle is a point where two lines meet. Good. So if the angle is less than 90, you say acute. So that's theta less than 90 degrees. So obtuse, that was what? Theta is less than 180, but theta is greater than 90. So how do you write this together? You say that 90, you write the lower boundary first. You can write the lower boundary and the upper boundary. Come and write theta in the middle. Is that okay? So that is the simple way to do it. Though. So you now say between 90 and theta, which one is greater? Theta, right? Okay, so see. Good. 90 is less than theta, less than this. So usually the shape, the buttocks is always facing the same place. So if the bum bum is facing here, the bum will face here too. Yes, theta is greater than 90. You understand now? But it's good to start from the lower bound. All right, how was the next one? Reflex, okay. You also know right angle. In between here and here, we have right angle. Right angle is what? 90 degrees. Equal to 90, theta is equal to 90 degrees. Right? All right. And then we said, okay, just let's go to this. Reflex angle, theta is greater than 180, but theta is less than 360. So what would that give us? 180 here, 360 here, our theta in the middle, so less than, right? So meaning that 180 is less than 360. No, no. We always work, the circle, the total, the sum of angles in the circle is what? 360. Do you understand? So if we have greater than that, we always work it to 60, to 360 degrees. There are different manipulations that we do. We've not done trig, right? And that's what we've not talked about it. All right. So, do you get this? All right. Now, we'll be discussing the next thing where we'll start axioms now. Axioms. Okay, I didn't mention supplementary angle and complementary. So that right angles are right angles complementary. All right. Supplementary. Good. 180 or angles on a straight line. Okay, we've not gotten to the axiom. But let's quickly talk about now this parallelism. This is where most of the questions are going to come out. It's usually going to appertain with parallelism or perpendicularity. You are going to see them when we solve them now. So you must always try to look out for parallelism or perpendicularity. So in most cases, you are going to see a line to cross both of them. That line is called what? Oh, a transversal. Do you understand? So this line crosses. Now I told you it could be more than this, right? It could be more. It could be more. All right. Now from here we can have various relationships because these two lines are parallel. So if they are parallel, it means that there are some points, and you know that an angle is where two lines meet, right? So these two lines, this line and this line meet here. This line and this line meet here. This line and this line meet here. But the thing is that this line and this line and this line have something in common, which is parallelism, right? So since they are parallel to one another, it means that there is something that is going to be about the angles. Do you understand? So for example, let's call this place A, B, C, D, E, F, G, H, I, J, K, L, I, J, K, L. All right. So we have that. All of these are angles. Is that okay? So there will be degrees, granite on them. All right. Now there are some axioms that um, we work with. Do you understand? All right. So the first axiom that you must know is the one that says angle on a straight line is equal to what? 180, or is what? Supplementary. Good. Angles on a straight line are supplementary. I told you how to remember that, right? This supplementary. Okay. Number two. Number two is angle at a point. Some of angles at a point is what? 360 degrees. Angles at a point. Those are basic anyway. Angles at a point. Okay. Now another one you should know is this. Now if I have angle on a straight line, to 180, what if I draw another straight line to intersect this? If a straight line intersects this, it means that I will have angle on a straight line here. That's what? 180. I can have angle on a straight line here. 180. Notice semicircle, right? Good. I can have angle on a straight line here. 180. Do you understand? So in a way, if you understand that maths, you will know that this place, the angle here, say A, is going to be angle here equal to the angle here, say Z. If the angle here, X, is going to be equal to the angle here, say Y. Do you understand? Say Y, because Y is long term. Do you understand? So we call these lines, these angles, and just look out for where there is a crossing. Do you understand? Where you notice a crossing, that will be that is where this axiom will work. And the axiom is what? Vertically opposite angles are equal. And I told you about the shorthand, right? You must know how to write them in shorthand, okay? Good, so we are done with that. So it therefore means that using that principle, this is axiom 3. No, let's start with axiom 1. Angles on a straight line are supplementary. So A plus B must give us what? A plus C, 180. B plus D, 180. And that even makes sense. Look at this. If A plus B gives us 180, so an A plus C must also give us 180. It means that C must be equal to what? So using what? Vertically opposite angle again, right? I mean, proving vertically opposite angles are equal. Do you get it? All right. Now, so this is equal to this, this is equal to this, this is equal to this, this is equal to this. So if you pick anything, if you pick any two sides or any, if you use any axiom, you should write them. Do you understand? Yes, because when you be presenting your written, when you're writing, taking a written exam, you have to present the axioms for which you are, you state the axiom that works with whatever you say. So for example, I could say that B is equal to C. I have to say Y. So Y is B equal to C. So this is how to shorten it. Vert, OPP, angles are equal. What do you say? As I say OPP, what do you say? All right, now number 3 is this. We have this side. Now, we have what we call here, we have what we call corresponding angles. We have what's called what? Corresponding angles. Are what? Equal. Now, what are corresponding angles? If you go to good, why are they corresponding? Because they lie on the same side of the transversal, of the point of intersection between the transversal and the parallel lines. That means J equal to B. You get it now. So B you said is equal to F and is equal to what? J. So using what? Cos angles are equal. You can just say corresponding angles. When you say this is equal to, so you say they are what? Corresponding angles. All right. So another one is K will be equal to what? In this place. In this first set, yes. K here will be equal to which one there? K. Oh, yes, but that's not what I expected. Using corresponding angles. K is here, it's equal to C. Of course, C is equal to B. So K should be equal to B too. Do you understand? Do you get it? All right. Equal to C. Do you understand? So those are corresponding angles. All right. Then the next axiom, which is the second to the last, is angles alternate angles, right? They are also what? Equal. All right. So what are alternate angles? I told you one name, the Z's and the knees. So when you see Z shape and knee shape because these two lines will be what? Parallel. And these two lines will be what? Parallel. So this will be their transversal. This will be their transversal. Do you understand? All right. So, and I told you your exam, what they just do is they just walk around these shapes in different ways. So, for example, you will just see them clean one part. They will not show you. So it is of you to now extend those parts that are incomplete. For example, look at this now. You could see, I'm still going to talk about the alternate angles in follow. I just want to show you what the variations you will see in the exam. So this is what we want to draw. This is what we intend to draw. But you know what your exam will do? Your exam will come up with maybe something like this again. And then now do this. Clean this part. Maybe you want, clean this part and maybe show you something like this, for example. So with this, you might be confused. Maybe you are given an angle here, and you are given an angle here. And then you're like, how do we find this? Now it's very simple. All you need to do is this. Extend this guy. So you know that this guy and this guy are what? Parallel. Now this, you will see this. You see this to show that they are parallel. It's okay, two arrows, an arrow like this. You might see two arrows too to show that It is more than one line. As in, the lines that are parallel are more than two there. Good. So then you now extend this one to up. So you can now say that this y will be equal to what? X plus a particular here. Do you understand now? So when you begin to find answers to your problem, from here you can get here. Here you can use angle in a triangle, some of angle in a triangle. Do you understand now? So those are the ways to go. But how do you recognize alternate angles? Now I said when you see Z's and E's, right? So angles that go like this and like this, they are what? Alternate angles. So using that, you see that here, C should be equal to what? F. Let's prove that. If C is equal to F, F is the same as B, right? Because using what? Corresponding angles. So, and we already said B is C, using what? Opposite angles. So definitely C must be F. Do you now understand? All right. So then we can also look at it in this direction, like this, like this. This is also a Z, only that the Z is stretching, right? Maybe it's tired. It's not stretching out. So you understand? So this place will be equal to this place. Do you understand? Right. So that's it. That's it for that. Now the last rule that you should know, of course, you should know that angle in sum of angles in a triangle 180 degrees. The other one you should know is that sum of opposite, you're just saying angles, opposite interior angles is, or you can just say opposite interior angles are supplementary. Do you understand? Or is equal to 180 granotes. Do you understand? Opposite interior angles are supplementary. Do you get it? Now, what are opposite interior angles? This place and this place. They are opposite interior. You see, they are inside. And they are facing each other, so they are opposite each other. Do you understand? This place and this place, they must what? So if I say H and J must be equal to 180. So what rule am I using? Rule 6 or axiom 6. They are called axioms. I told you. Axioms are also rules. Is that okay? Right. It's just another way of saying rules or laws. All right. Now, let's go on to working on problems. Let's find solutions to problems. I told you I found fine questions there, right? All right, go and sit down. Okay, so in this one, we have, look at these two fine questions. Two fine questions. Are you with me? Okay, look at this shape. Let's start with this one. This one says you solve this, right? Okay. So this one says this and this. So what does this show? Complementary. Yeah. This one says this is 2A and this one is 42 granotes and this one is A. Alright. So we'll say that what? 2A plus 42 granotes plus A granotes is equal to what? 90. Complementary. So just say comp angles, right? So that's the way you can shorten it, the shorthand, instead of writing complementary angles in full. All right, so here we are going to have this plus this will give us what? 3a plus 42. Are you with me? All right, so we have 3a is equal to this will subtract this. That will be 48, right? So a will be equal to divide both sides by 3, you get what? 16. So a is 16 granite. Do you understand? All right, let's go to the next one. I guess these ones are simple, right? Is it everything that is simple? Here? Wait, you were able to do this F by yourself? And let's see now. So let's see if it was nonsense you did. So here we have 4x plus 20 granite and 5x minus 11 granite, right? So what do we do? This becomes, you know that, which rule do we use here first? Let me know. Which rule? We have to find A. Do you know? You didn't do this. But we even asked to find A. We have to find A. So how are we going to find A? You know that this A is equal to this, right? Yes, you know A is equal to this, right? Using opposite angles. But we can use the rule, the last rule, sum of opposite interior angles. So that is 4x plus 20 is equal to what? 5x minus 11. No. Plus this is equal to 180. Old man, you're saying yes. But do you understand? Eh? So the sum of this guy and this guy should give us 180. What's the axiom? Opposite interior angles are sup. Sup. Something like that. You understand? All right, so 4x plus 5x, 9x plus 20 minus this, 9 is equal to 180. So 9x is equal to this minus that, 171. Can 9 divide? Do you remember what the rule? If it adds up to 9, 9 can divide. So this plus this, 8. 8 plus 1, 9. So 9 can divide. Do you understand what I did? All right. So 9 this to give us this in 17, 1. Remainder 8 to 19. So the answer is 19 granotes. X is 19 granotes. So we have to find this place now, right? So this place will be 4 into bracket 19 plus 20, right? So 4 times 19 will give us what? 6, 5, 56, 76 rather. That's 3. 3 plus 20, right? That will be 96 grams. So it means that A is equal to what? 96 grams. Do you understand? Did you get it? You're forming your. But it's simple. No? You never started. Old man. Did you get it? At least thank God you understand. You are still going to solve 120 questions. You don't know anything. You will know. As I'm sending to them, I'm going to be sending to you. Are you here? Let's go to the next one. Look at this shape. Now this shape is crazy. So I doubt if you even got it. So notice that this guy and this guy are parallel. Oh, I told you failed it without even knowing yet. What's your y? It says you find y here. What's your y? You didn't do y, yet you got it. Okay, you are convinced you got it. What's your y? So this place says 2x minus 20. Please check if it's clear enough, Alpha. Okay. The questions are visible? Okay. Okay, so here, this is the question. It now says to find, okay, it also asks us to find z. What's your z? All right, let's do it together. Let's do it together. So what you want to do here is this. Always take note of the parallel lines. Is that okay? So one thing I want to do is let me extend these lines first. You know, I like to do this so that it will make my work visible. I mean, the workspace bigger and clearer. Is that okay? So I have my transversals, right? So now I can view this in terms of this transversal or this other transversal. Are you with me? You're not looking at the board. So see this. Look at what I want to do. If I view this, are you here? If I view this in terms of this my transversal here, it means that, no, let's view in terms of this transversal. It's easier first. Do you know why? Yes, it's easier. Look here. If we view in terms of this transversal here, this place is 154, right? So using corresponding angle should be equal to, it should be equal with this place, isn't it? So this place should also be what? 154 grams. Did you see that? This place using corresponding angles should be equal. So this place should now be what? Angle on a straight line, right? So using angle on a straight line, this Z will now be what? If you subtract this from 180, what will you get? So let's say Z plus 154 grams is equal to 180 using angles on straight line. Straight line. That's 26, right? So Z is 26 grams. You got it? Really? Okay. Now, so this place is 26. We have found the answer. Now, the next thing to do is this. We can, you know that, look at this. Are we here? You know, with respect to this other transversal, you are with me, right? This place should be equal to where? This place, right? So it means that, and if this place is equal to this place, it means that using, oh God. This place is equal to this place, right? So 4x minus 88 is the same here. So this, yes, using corresponding angles you produce here, right? Okay, let me clean this. So we are saying that this place is definitely 4x minus 88 grams. So how do you relate it to this place? Vertically opposite angles. So it means that 4x minus 88 should be equal to 2x minus 20. Do you now understand? Alright, so from here we have 4x minus 2x is equal to minus 20 plus 88. So this gives us 2x equals 68. So x equals 34 grams. Is it not simple? So now, here, we've gotten, okay, we've not gotten what is there. So let's now use our 34, our x, to get what is there. So it says it's 2x minus 20. So that will be 2x, that is 2 into bracket 34 minus 20. 68 minus 20, that's what? 48. So this way is what? 48. Are you following me? All right. Now, if this way is 26, this place too must be 26 using alternate angles. This place, where? Here, right? 48. So, yeah, you can use anywhere that is close to here. I wanted to use this place to find here, but let's use here now. So, do you remember this rule? Okay, there is a third rule that you should know with triangles anyway. That sum of no, sum of two interior angle, sum of two interior angles, yes, is equal to opposite exterior angle. You see, remember how it works, right? So opposite exterior angle. So if I have my triangle like this, and I have here to be A, here to be B, here to be C. If I extend any part, maybe I extend this one part here. This place, if I say this is x should be equal to what? A plus B, old man. So if I extend this place out, it should be these two that will give me this outside. Why? Because this place is what? 180. And everything here should give me 180 normally. You know, right? So it means that it's only this place that is remaining for us to get 180. So if these two must be added to this to give me 180, definitely this place must be these two too. You understand, right? Okay, what if I say to find Z here? It will be the sum of what? BC. Do you not understand now? B plus C rather. Do you get it? So using that principle here, we can say sum of this plus this will give us Y. Isn't it? So Y is equal to 26 plus 48. And that's what 74 or not. Did you get it? Oh, old man. All right, let's solve another question. Let me clean the board. All right, so let's attempt these two questions. I want us to start with this. Since you said it's simple, let's start with this. Okay, so what we want to do is, you see the way they get the question. So you have to extend this. So if you extend this, well, this will become our what? Transversal, right? So this becomes a transversal. If this place is a transversal, so this place must be equal to this place using what? Corresponding angles. All right. You know, you can actually name it. If this was in, are you here? If this was in theory, you should letter this place by yourself like this. See, you should come here and say maybe C. You get it? So you now say C is equal to 110 using into bracket corresponding. Do you get it? Do you understand me? So this is now 110. So how do you find B now? So B plus 110 will be equal to 180. How is that? B plus 110 is 180. So B should be what? 70. And you say you got it to.
Like this.
This line, you use this. Huh? You use this as
Yes, like this.
yeah, this Z, so this should be equal to 110. Yes.
Oh.
So this plus this will not give us 180 still. Either way you do it. Do you understand? So here, 110. So how do we find A? A very smart way to find A is this. One thing you can do is just come here, come and find this place. If this place is 130, what will this place be? 50. Why? I'm going a straight line. You with me? You understand, right? This plus this is 180, right? So how do we now find A now? We've gotten B to be what? 70. And everything here, what's this? Triangle. So everything here will be 50 plus B, which is now 70, plus A should be what? 180. What's the axiom? Good. So this is 120. A plus 120 granote is equal to 180 granote. So A equal to 60 granote. Do you understand? You failed it.
No.
Did you get it? All right, let's solve this second one. This second one is not as easy, so follow me as I solve. Do you understand? I mean, it's not like it's not easy, but I don't think it's going to be as cheap as that one. Just watch. So what do we do here? We have found two parallel lines. I think I didn't put that arrow, but it would have been put in the question. So look here. Now listen, if the parallel lines, if that's arrows, those two arrows are not put, it means they are not parallel. If they are parallel, there should be no, except for sometimes, which is very rare, where they will make mistake of typographical error and where they will not include it. So what you want to do is this. Since these guys are parallel, you can erect, we have two transversals. Is either use this as one of the transversals. If you use it as one of the transversal, we have created a triangle here, right? Good. So if we use it as our transversal, means that this angle here will be equal to this angle here. Am I lying? So this will be 3y. God bless you. Using vertically opposite angles. Good. So what would this place now be? 136 plus that place. Let's call it A. Plus A is equal to what? 180. So we have 136. A will be equal to 180 minus 136. That's what? 44, right? A is equal to what? 44 granote. Do you understand? So we now say that 5y plus 3y plus A, which is now 44, should be equal to what? What's the axis? The natural angle. So this was this 8y is equal to 180 minus 44. So 8y. Oh, you know we needn't even do all this. Do you know why? Because from here we can just say this should be equal to opposite exterior. You get it right? So 8y again is equal to 136. Do you understand? So divide both sides by 8. 2 here 4, 2 here 6, 8. 2 here 2, 3 here 34, 2 here 1, 2 here 74, 17. So y is equal to 17 grams. Do you understand? So that'll be it for this video. If you have, I'm sure that you gained value. Do it to subscribe to the channel and click the bell notification to be notified whenever I drop a new video. Subscribe. Subscribe. It won't hurt you. God bless you.